You guys hear me okay? Is that coming through?
Yes, sir.
Move the center. Is that better? Does that pick it up okay? Turn it up. All right. So my name is Robert Mortensen. I work for NIWeek, and this is How to Architect a Framework, SquareBattle. Thank you all for coming. Appreciate you being here. I graduated with a degree in computer engineering from BYU, and came to work at National Instruments right out of college, and came and lived in Austin, Texas here, within this beautiful campus, and did that for about 3 years. And when I joined National Instruments, I hadn't used LabVIEW at all before, and I really fell in love with it. Since then, I've really gained a passion for LabVIEW, and I love how LabVIEW abstracts away the artificial complexity inherent in text-based languages. That's a marketing phrase there we used to say, but it really struck home with me because I took, computer engineering is supposed to be a double E core with some CS classes. And I like my CS classes, but the text-based stuff, I got it, but there was just, always seemed like there was all this stuff involved with make files and having to do stuff. And LabVIEW was so simple. There's nothing as beautiful to me as a blank DI. It's a beautiful canvas. And LabVIEW can be so fun, and that's part of what we're going to do today. Talk about how fun it can be, and that's why we did SquareBattle, which I'll introduce in a little bit. After leaving National Instruments, I found I liked using LabVIEW more than making it and supporting it and teaching it. And so I left to work for an integrator in Utah. Went back to school, got my MBA at BYU. And about 5 years ago, I founded NIWeek, which is a Silver Alliance partner. And I get to work now with Sean Walpole and Carl Becker, who are both here, two of my co-workers. I'm a certified LabVIEW architect. I'm a certified LabVIEW embedded developer. I believe that I was actually the first one to get that. I'm the world's second fastest LabVIEW programmer. First place going to Darren. Is Darren here? Okay, so SquareBattle. Who's been on the demo floor and seen SquareBattle down there already? About half of you? Okay, good. So what I'm going to do, I'm going to introduce SquareBattle, and then we're going to talk about some architecture in LabVIEW, some decisions you want to make in architecting, mainly about some things like loops, how many loops you want to use, communication between those loops. We'll talk about classes a little bit at a basic level, and then what I'm going to do is relate those points, those architecture points, to SquareBattle and how we used it in SquareBattle. I'm kind of light on the slides and heavy on LabVIEW. So I'll be doing a lot of demoing and walking through LabVIEW because LabVIEW is great. I'd rather see that than slides. And so I invite any questions you have during the presentation, feel free to raise your hand. I'll leave time at the end for questions and answers as well. So I want this to be interactive, more of a user group feel if you guys are up for that. If you're here just in the post-lunch coma, that's fine. Just sit back and we'll try and entertain you. Okay, so SquareBattle. So about a year ago, we were sitting around. I'll tell you a story here. We're sitting around talking about LabVIEW, because LabVIEW is great. And Sean, I believe it was, said, hey, back in computer science at college, we had this class where we had to learn to program this thing. We had this game. And I don't know exactly how it came up, but we'd say, hey, we can do that in LabVIEW. Let's try that in LabVIEW. And who plays computer games out there? Any gamers here? Okay, again, about half of you. That's good. I like computer games as well. I'm more of a strategy, turn-based type gamer. And I find myself a lot of times playing these games and getting to the point of that game where I'm like, I wish I could automate this. I wish I could just tell it what to do. I don't have to go through all the steps. Just tell it what to do and have it do its thing and see where that goes. Well, SquareBattle is kind of an effort to do that. You get to tell your team ahead of time what to do. You write the code that then goes and plays against or battles other people's code. kind of the cool idea. So that's kind of the genesis of SquareBattle. We wanted it to be a very, very simple interface, something that would be really easy to go in and add your code to. And so all you really have to do is override a method of a parent class to create a competitor in SquareBattle. It's a plug-in architecture. You can just drop the code in while it's running, and it'll pick it up and go with it. And that's what we've got down on the floor that you'll all go see. So to kind of show it out here, I'm going to show some code, introduce it. All right, so on the right side here, we have the arena, which is it's an intensity graph. You can pick the size. By default, it's 150 by 150. Okay, that's kind of the arena. That's where things happen. On the left here, we can pick the competitors. And to start out, I'm going to show a simple competition. We're going to, so these are all the competitors we have here. Assassin, we're going to do that versus one called Sir Robin. Okay. And down here we can start the battle. We can control the game speed, how many rounds per second we do. I'm going to slow that down. Start here, we'll do 10 rounds a second. Start the battle. And both Assassin and Sir Robin start out with one square. And we can see that Assassin, can you guys see that okay? We need to turn lights down. Is that showing up okay? You want to dim the lights? Dim the lights. We can see that Assassin's kind of running around here. Sir Robin is this green one, and he's just kind of sitting there. So each team starts with one square. And those squares, each round, we're already on round 270 now, each round, each square gets to do one of four things. It can wait, so just sit there and do nothing, which is what Sir Robin is doing. It can move, which is what Assassin is doing here. It can attack an adjacent square and eliminate a square if it's there. Or it can replicate. And so we see Assassin has found Sir Robin, and Assassin just tries to go in and attack someone without replicating, and Sir Robin just runs away when he sees someone. And so it's a little bit boring, but good for explanation, I guess. For some reason, my kids love this one. If we speed it up here, we see that they'll just keep playing this little game over and over again. And my kids just get a kick out of that for some reason. I'm not sure why, but they could watch that forever. Okay, so we're on round 7,000. So this goes pretty quick here.
So attack is fruitless?
So the way, good question. So he's asking this, is an attack fruitless? So what's happening is Assassin is attacking the square, or the location that Sir Robin is occupying. But Sir Robin is running away from that square when it sees Assassin. So they can only see the 8 squares right around them, so they only know they're there when they're right next to each other. And if a square ends its turn in a location that has been attacked, it'll be eliminated. Or if it ends its turn in a square where another square ends its turn, then they'll both be eliminated. And so what's happening is when you attack an adjacent square, you don't move into that square. So it's attacking, but Sir Robin's moving away, and so he's swinging and he's missing. He's not eliminating him. Okay. So very, very basic, simple example. But good question. Any other questions? Yeah. Yeah, this is kind of a stalemate. You've got one that always attacks, one that always runs away. This is a stalemate. This isn't really going to go anywhere. These two competitors are kind of demonstration competitors. They're not meant to be competitive.
The most squares possible. Yeah, what's the overall goal?
So the overall goal is to eliminate the other ones. Or I think downstairs we have a time limit on it, so you want the most squares by the time the time limit runs out.
Elimination is still possible or not? Or not in this case?
Well, in this case, you'd have to beat Sir Robin, you have to have more squares and surround him, and then you couldn't get away. I'll show more. You'll get it as we go on here. That's just a very, very basic start. Okay, let's try a different one here. So I'll end that battle. Let's do one called Expand, which just sits there and gets bigger, versus one called Cautious Wolf. Okay. So when you expand, when you replicate, you immediately create a copy yourself in a certain direction. And then both of those squares have to sit there. You pay a penalty of 100 rounds. So you're vulnerable, sitting there for 100 rounds every time you spawn. Yep. And so you can see we're waiting here for 100 rounds to go by. And then as soon as that 100 rounds is up, both those squares can go do something else. They can replicate again, or they can move around and tap whatever they want to do. So we can see that expand is just kind of staying here and expanding. Cautious wolf is kind of spreading out and moving around and expanding occasionally. Speed that up a little bit here. A little too fast. So we can see that expand is just kind of staying there. Cautious wolf is kind of spreading out. And so what this boils down to, strategy-wise, is kind of a balance between how much do I expand by replicating and how much do I go attack other players. That's kind of what the main strategy balance is. Okay, let me show one more, and then we'll get into some architectures and code here. All right, let's try Pinwheel versus Brain. Now, quick story here. Pinwheel is one I wrote. Brain is one that Carl's brother wrote, who had not done LabVIEW before. This was his first foray into LabVIEW, and did an excellent job. I think it's one of the prettiest ones I've seen. So this can be done by anyone, LabVIEW experience or no. Yeah. What do you got?
One thing might be to say that also if you're completely surrounded, then you can't really do anything. So you can see that some of the ones that spread out do a little better than the ones that just sort of fade in. Like my one that you'll see down on the floor just sort of kind of does similar to what Expand does. It just kind of grows out from the center. And that means all of the guys that are stuck in the middle can't do anything because they're all landlocked.
But he's still #1 in the tournament right now.
Because I'm the only one that entered.
All right, let's try Pinwheel versus Rain here. And a couple other things I want to highlight is up here we show how many squares each one has, and it sorts them. So who's over on top will be the top player here. And then we have some other stats here. I don't know if you can see that too well, but we have how many squares that team has generated, how many that team has eliminated, or how many of those squares have been eliminated, how many kills that team has, and how many collisions each team has. And a collision is when you kill yourself, when you kind of run into yourself and get eliminated that way. And so what's happening here is Pinwheel kind of has its outer shell to protect itself, and it grows outward. And Rain just looks like Rain and kind of does some cool things. Let's speed this up here.
So if you're landlocked, how are you getting holes inside the landlock by killing yourself?
Every time it expands.
Whenever it expands, whenever it increases its border, it's having to move out. And if something's moving in at the same time that it moves out, then they'll both be eliminated. Yeah. Okay. So Pinwheel finally expands out and eliminates Rain on that. Okay, so any questions on gameplay, how that works, what the point of this is?
So there's 4 options.
Yes, 4
And
options.
So each type of character has some sort of statistical tendency of what he'll do on each one, or is he pretty much programmed to do?
It's up to you. It's whoever programs it can, and we'll get into the code a little bit more later on, but you've got 4 options, and you get to pick what. So each square runs a VI each round and decides what to do. And we'll show that later on. Other questions about just the gameplay format here? Interface, yeah.
This was inspired by Conway's Game of Life. Is that
A lot of people have said that. I have seen Conway's Game of Life. There are similarities there, and some of that thinking went into this. Rules are a little different, but yeah, a lot of similarities there. Yeah.
Who created the rules for this?
We kind of, as a team, me, Sean, and Carl, talked through different ways of doing this, and there's different trade-offs for how we wanted to do things. We talked it out as a team and kind of came up with the rules.
But this is your idea?
This is our idea, yeah. And we ended up doing this at some user group meetings in our area. We had some good success with that. And we're not trying to monetize this or anything. This is just kind of a fun way. I used this at one of my LabVIEW Basics classes. I was teaching LabVIEw Basics, and it left some time at the end for my students to teach them this and go through it. And they all came through and spent about an hour creating a square, and all of them came up with something that did something, and it was really kind of fun.
So you're saying, without any of that, the experience, you throw them into object-oriented stuff, and they
Right, so the question is talking about LabVIEW classes, and yes, the idea is, so LabVIEW Basics 1 and 2 does not have any classes in it, unfortunately. Or what? Core 1 and 2. What's that?
There is no object-oriented.
Right, there's no object-oriented in Core 1 and 2, and I wanted to throw a little bit of object-oriented in there, so I did this at the end. And we'll get into classes a little later and show how to override a parent. And so yeah, it was just kind of an introduction to classes and how to, yeah.
I'm a newer user,
Okay.
and the idea of being able to drop things in while it's running is very appealing.
Yeah.
Does that only work, I mean, if you build your thing instead of just running it in the LabVIEW environment, if you already have it as a compiler for a build object, if that's still possible?
So that's a great question. He was asking about plugin architectures, how to just drop the code and have it work. Let's, if we have time at the end, we'll get into that, or come up afterwards and we'll talk about it. That's a great topic.
Do you have a slide, or can you say what those discrete 4 rules are again?
We'll get into it later, but I'll say it real quick. It's wait, so do nothing, no off basically. Move to one of the 8 squares right around you. Attack one of the 8 squares right around you, or replicate to one of the 8 squares right around you.
And you know what of what's in those squares, right?
You know, you get to view what's in those squares. Yep. Yep. Yeah, question?
On your classes for your inheritance, you said that each one of those nodes is a class, and then you're
Yes.
inheriting from that class. Can you have sub-inheritance on your own class underneath that to kind of create some greater complexity in your design, or are you limited to one single
That is
layer?
a great question, and yes, you can. The easy answer is yes, you can. We'll get into that more towards the end of the presentation. Great question. Other questions before we move on? Okay. All right. All right, jumping back to slides. Let's talk architecture a little bit. So an architecture should fit the needs and the constraints of your project. Okay. A lot of times I see the opposite. I see LabVIEW code that is written with the architecture already done, and someone tries to take an architecture and make it work for a certain project. And a lot of times I think that's like doing this, trying to hammer in a screw. You really want your architecture to fit the project, and not the other way around. So in order to do that, I think one of the most important things you do up front is design that project and ask yourself the right questions up front. And so in talking about, let's talk about loops for a little bit. What are some key questions to ask yourself when designing your application as far as how many loops you want? We may want to ask ourselves, well, how many loops do I need? What's all going on? Do I need to handle user events? Or is this an FPGA? Is this an RT? Do I not have a user interface? What timing constraints do I have? What different hardware APIs will I be using? Who all am I talking to? What deterministic requirements do I have? And then once kind of you figure out what loops you're going to be using in your application, what rate are each of these loops going to be running at? These are all great questions to design up front before you get into code. Now, as an Alliance member out in Utah, we do a lot of smaller applications, a lot of clients, a lot of small projects. And so I've gone through this process quite a bit for a lot of these small applications. I know larger applications have a different design process, but a lot of what I'll be talking about is more geared towards these smaller applications. So I remember doing one RT application where I knew I'd be doing a lot of different things, and so my first thought was, okay, this is going to have like 5 or 6 different loops. Because I have to talk to the host, I've got to talk to a PLC, I've got some cameras that I'm going to be grabbing images from. I have to do some pretty heavy image processing. And so I have to do some DAC triggering to trigger these cameras. So all these different things have to happen, talk to lots of different things. So I'm thinking of maybe 5 or 6 loops. But as I looked at it some more and saw some of the constraints between these different things that needed to happen, I found that certain pieces of that code only ran when they were triggered by other events. And so I boiled it down and figured out that I ended up using only 2 loops in the whole application. And I've done other projects where I thought, okay, this is a very simple application. I'm just going to do probably 2 loops at the most, one user interface and one to handle some of the logic, business logic. And I get into it and design it, and oh, actually I need to do this. I don't want my logging to slow down my acquisition, and start adding more loops. So sometimes you're going to add more, sometimes you're going to put them together. I've seen a lot of applications that have too many loops in them, perhaps. Active Framework might be an example there. Sometimes it's called for, sometimes you need that many loops. Sometimes I've seen a lot of applications that have too few loops. I'm sure you guys have seen some of those where you've got just one giant loop and it's having to do a lot of polling of controls to get, and you're trying to do your user interface through polling. And I've seen some where you've got the big event structure to handle events, and then you're doing tons of logic in the timeout case of that. There's maybe situations where you want to separate those loops out. So you want to kind of ask yourself some of these questions, figure out how many loops you should have.
How many APIs running in parallel?
Yeah, maybe how many, so if you have things that need to happen in parallel, what if you have certain APIs that need to happen in parallel, you may want to consider using multiple loops.
Why not say that it's separate, running in parallel, full stop, so it's the same.
So he's talking about maybe doing some data acquisition. Maybe data acquisition would be in a separate loop. A lot of times you'll do data acquisition and use the triggering off the buffer. You want to read so many samples from the buffer to control the timing of that loop. That's a great example where you want to do a separate loop for the data acquisition.
You can put it total in a separate API. Why do you have to stack them in the same API?
Right. Oh, why do you have to stack the?
Loops in the same API instead of putting them in separate APIs.
Yeah, and so those loops can either be in separate VIs or the same VI, and that's more of a personal decision, I think. Yeah, both of them work, and they'll still run in parallel that way. So looking at these questions for SquareBattle, what type of loops are we going to need for SquareBattle? We're not having any hardware. Could it all just be done in one loop? Why might we want to separate loops out?
It's basically every time.
There's a lot of squares sometimes.
At every moment, you have to process them sequentially. What the next one will do, go up, cannot be the same.
Right, so you may want to process some of those squares sequentially, but
Are you talking about the overall framework or an individual player?
I'm talking about the overall framework. Good question. Yeah, let me clarify that. So in looking at, I've shown you the user interface and kind of how the whole program works. Looking at that application, if that was your project and those were your constraints, yeah, how many loops do you think we'd want, what would we want different loops for?
Well, I don't know exactly how many loops, but you have to think that, your board was 150 by 150. So I don't do the math, that's how many elements that you're cycling through every single one of those elements to see if there's a square there and what needs to be
Okay.
processed.
So there's about 20,000 squares there. That's quite a bit.
Yeah.
Right, you can have as many loops, so you can have a
Maybe it's-
square living its own life and its own.
That would be one way to do it. Have a loop for each individual square. One thought. Other thoughts?
For each player.
Loop for each player might be a way to do it. Other thoughts? What was that, Will?
State machines.
State machines? A loop to do state
Two.
machines? 2 loops?
2 loops.
What,
2 loops are better.
do we need, so there were some, should I go back to, there were some controls there.
2 loops per square.
We've got some buttons we got to take care of. One other thing you do is you can pan this as well. The arena just wraps around. So we need to handle some user interface stuff. So we probably want a loop to handle buttons, maybe an event loop, we want. And then maybe loops to handle all the different players.
But do you have actually any insight into each square line? No, right? You don't, each of your squares, you cannot loop into its state individually, right?
Definitely not ahead of time. Yeah. Okay, well, let's jump into some code and show what we ended up doing here. So we ended up architecting it with 3 loops. The top one for user events, and then the bottom one to handle the game engine, all the actual stuff happening. And then we ended up adding another loop for the front panel updates, which a lot of work went into this to optimize it. We wanted this to run really fast, and so we could get through games really quickly. And we found that we could tie the front panel should only update every time, only needs to update every time we run a round of gameplay. But we found that that would slow it down quite a bit. We decided to have the game engine happen. Each iteration of this game engine loop would be one round of gameplay. And so we have this game engine that handles one round of play. And this loop, another constraint we had was we wanted, remember how I changed the game timing, the game speed? We need to have a separate loop to control that, so we control the speed of that. And then sometimes that, let's see, when we do a simple battle, I'll just do Assassin's Creed Robin again. Notice how many, what our actual game speed is. We're running 700 to 800 rounds per second. That's pretty fast. We can get going pretty fast. There is no reason we need to update the user interface that fast, right? Let's try that out though. If we were to take this user interface update code and stick it in the same loop as the game engine, so say we combine those two loops and run it again. Notice that drops our speed down to 200, 250. So we're looking at a 2 to 3 time improvement by moving the code that updates the front panel to a separate loop. So if efficiency is a constraint, then you're really good to separate that out. And then we knew we have all those different squares and locations happening at the same time. So someone said maybe doing a separate loop for each one. Well, my laptop has 8 processors on it, and we want to utilize all those processors. And so if we had them in different loops, we could, in theory, use those processors. There's other ways of doing that, though. In the game engine here, part of the core game engine is this nested for loops that iterate through the entire arena. And handle code for each square. And on this outer loop here, who knows what this key is right here? Has anyone done parallelized for loops? So you can, that key says, hey, I want to take these iterations, these different iterations of the for loop, and assign them to different processors, have them all run in parallel. And so even though there's not a separate while loop here, taking those for loops and parallelizing them is effectively putting them in separate loops, letting them run at their own rates, and using all those processors. That's a really good trick to do. And in practice, that sped up our execution quite a bit as well.
So how do you do that with the theory?
So the question is, how do you parallelize? So if you right-click on the border of a for loop, there's an option here for configure iteration parallelism. You've got some options there. By default, this is turned off in for loops, but you can turn it on. You can then specify the number of generated parallel loop instances, and you can match that to how many cores you're going to have running. There's no point in doing more than the cores you have, because you won't be able to be going faster than that.
You can also wire into the key.
Right. If you need that to be programmatic, you can also input into the P. That's a neat trick for speeding things up. It does come with some constraints, though. LabVIEW won't let you add that to for loops that have dependencies between each run. Like if you had a shift register, there's a dependency there, right? You have to have the outputs of one iteration before you can run the code in the next iteration. So if you have like a shift register or a feedback node or any other constraints, you can't do that parallelism. But in this case, we designed it so we could. We can run all of these iterations out of order, and it's just fine. And that costs a lot of efficiency. So is there a question?
Is the code available?
Is the code available? The code is available on our website, NIWeek.com. I've got some cards up here with info and links if you want to come grab them after the presentation. Yeah, this is all free, open source.
If you Google SquareBattle, I think the community page comes up as one of the first things.
That will work as well. All right, so any other questions about loops? So I've seen a lot of code, and I've taken over code from different developers who kind of get hung up on having to create multiple loops.
Question.
Yeah, question.
Updating the battlefield. You don't want to use those in-place stuff to make sure in-place element structure to update. So just going out to things like that as fast as possible.
So what's the question?
So you basically take that every time update. The battlefield.
You're talking about this
About the
2D array?
The battlefield itself.
Oh, about the update right here?
It's basically never right. We calculate every time. If you want to, you just calculate it like that. The question was, is using those in place, how would you say, or this is
Okay, so this array, this is an intensity graph.
Yeah.
Yeah, and there's no other way of,
He's saying to get the data out of whatever structure into that.
oh. So you're saying, how do we get that data into the, so what we do is,
Store that data somewhere, right? And then you just output it to that graph, right? You modify that being array. 150 by 150 every time you have it, right?
yes, so we take our map, our 2D array that's representing the whole arena, and we pull out what teams are on in each square.
Okay. And output into the indicator itself is just plain.
Yep. And then wire directly into the indicator. Yeah, there's no other way. You have to create a copy of that data to get it to the indicator.
Okay. So, yeah, I was thinking that you were actually using that indicator as a...
No, we do not use that intensity graph as storage for the data. That's just for updates, yeah. Because we may be updating that a lot slower than the game engine is actually running.
So you store it in that local variable map?
Yes.
That's where you actually update.
Yep. We store it all in this map. Yep, which we'll get to globals in a minute. Yeah, so just one other point. So we control the game engine speed with that front panel control, right? And then we're measuring how fast that game engine is actually running to show how many rounds per second we're going. And there's no point in updating our front panel any faster than the game engine is running. And there's no point in running it faster than about 60 curves, because that's our screen refresh rate, right? And so we take that speed of whatever the game engine's running and tie our front panel updates to that, but put limits on it and say, hey, don't go any faster than 60 hertz and don't go any slower than about once a second, because that same code updates when we pan. You saw me panning the arena. We want that to update and be responsive to the user. And so we want it to go at least that fast. And so that's how we time that front panel update loop. Yeah, question?
Okay, so you've got your global data that is keeping track of what's actually on the board and that's getting updated. Then I'm assuming in your battle that loop, the loops within the loops iterates the number of times of squares that you actually have active on the board.
Correct. It actually iterates through every square, whether it's active or not.
Okay.
So you don't use parts of that?
No. So if there's nothing there, then we'll run this case, which has no code.
So then each square is iterated, and at some point, you've got two squares that are going to interact, and somebody knows, hey, there's somebody here, or there's not. And then when the next iteration comes along, maybe it moves something in.
Yeah.
Seems like a race condition.
Yeah.
And also when you're updating your global map.
That's very perceptive of you. So he's saying there's potential race condition there because you're updating all these things at the same time. And that was a big problem we ran into.
And then the last half of that is if you've got, say, 4 processors running 4 parallel, it's like you've got a potential race condition there too. How do you handle that?
We had to be very tricky in how we handled that. And the short answer is all the squares, when they run, are working off a copy of the map from last round. And they all make their moves based on what was information from last round. And we copy those moves, that's why we have a DVR here. We copy those moves into a new copy of the arena. And then once all those moves are made, then we arbitrate them all and move on to the next round.
But if one move actually affects when they run square, its decision can change.
But it won't affect it till the next round. You don't know, so in effect, they're all moving simultaneously.
So they make the decision simultaneously
Mhm.
based on this instance of the map.
Correct. Yep, they all make the decisions based on that global map from the current round. Yeah, question?
Clarification request. If there was a duel, you're saying when it all happens simultaneously.
Right.
If there's ever a duel, both parties always die. Is that correct?
So if you had two squares next to each other and they both attacked each other,
Yes.
I believe that's what you're saying, then both would be eliminated. Yes.
So there's never one attacks the other attacks the first, but one goes away before the attack can be accounted.
No, it's considered simultaneous. They both get to move that round. They both attack each other and eliminate each other.
How are you merging? See it.
How are we merging?
Yeah, because it's the thing, everybody has their own unique map. Every player
Right,
has their decision that they go through the entire map. They
right,
make their choice.
right,
And then so X number of players, you've got X number of layers of new positions.
right.
And then you've got to hold them and then merge them, right?
Right.
It's set, basically.
So,
Okay.
and if three people try to move to the same square, which one survives?
Yeah,
They all
so
die.
you want to see the magic then is what you're saying?
Yes.
No, the question is more.
Oh, no, I want to see the magic.
Are the rules conflictless in that sense?
Are the rules conflictless?
Yes, so in the sense that regardless of whichever decision a particular square makes, it's all compatible, right? With
Yeah.
any other square. There are no incompatible decisions.
There are no incompatible decisions. Yeah, everyone gets to make their decisions based on what happened last round, and then we go through and arbitrate all those decisions. So the magic is this DVR. We have a DVR, so data value reference. They're very good. It's a, yeah, we'll get into it in a minute. It's a way of storing, sharing state data. All the magic happens in this VI right here, handle collision. So when any move, well, let me back up. So here are 4 actions. Here's a case structure that handles the 4 actions. We've got wait, move, attack, and replicate, right? And what happens is we don't care which one we do first. Whatever happens, if they move or attack, if they move into a spot, we put them in that new spot. If a location is attacked, we assign that location as attacked. Okay.
I think that square already decided to move away.
No, the location.
We mark a location in that 2D array as attacked. And if anyone moves into that location or anyone ends up in that location at the end of the round, they're going to be eliminated.
Even if they weren't there before, if they move into.
If they move into a square that someone has attacked, yes, then they'll be eliminated.
Right, so like you said, there are 2 ways to die. Either you end up in a location that's attacked, or you end up in a location where someone else is. Those are the 2 ways you.
Where is that? So if I say attack, and what's the difference between attacking a square and just moving to the square?
When you attack, you don't move in that square. You're just like swinging your axe at that square.
Oh.
And I'm attacking that square. You stay in your same position. You don't move
So
there.
it's not combined with the move.
Yeah, I saw a bunch of hands go up.
So if you
Question?
had a person here and he sees an 8 squares, there's nobody around him, so a person here, and there's 8 squares, there's nobody around him, so both try to move here.
If they both try to move in the same position, they'll both be eliminated.
Okay.
Yep,
Even if you're on the same team.
yep.
What's the race condition? I'm not seeing that problem.
The potential race condition, do you want to describe that, Norm? You were talking about?
Well, I was thinking about if you've got 2 people trying to move into the same square, well, that was one of them. They're going to eliminate each other, but what about the third one that comes in?
It's
So-
still not a race condition.
Well, no, but
It depends on how you have it. It's a potential.
that might not be the one
It's
that I was
a-
talking about. I was just thinking a couple of them.
There's a lot of potential race conditions here, and this is how we get around it by having these 2 copies.
You have 2 copies?
Yeah, so we got the copy from the previous round, that like before any moves are made,
Yeah.
and anytime, so as we iterate through and people and different squares make their decisions, we copy the effects of those decisions into a new map.
So you're not changing the previous round for any of them?
Nope, we're not changing the previous round. We're keeping that as it is. So going back to this map, this 2D array is coming in, and it is not changing at all as we're iterating through everything. The only changes are made in this brand new copy of the 2D array. That's how we keep them separate. And then once all those changes have been made in the new iteration, we go through and clear all the attacks and eliminate all the people that have been eliminated, and then copy it back into our map.
Another key thing is that we discovered that we could process them, essentially, any move you make, we can take care of that right then, in that round. And we don't have to wait and see what everybody else does just because of how we implemented the rules.
So there's no race conditions if you can do that?
Right, it precludes, it gets us away from any race conditions. Any other questions? Okay, we are really going over time. This is great, though. I love the discussion. So we may have to jump ahead in some of the slides here. So I want to get to, I'm going to show creating a new square. So real quick, let's talk about communication. So a lot of developers have a hard time. It's a big hurdle to go from a single loop to multiple loops in your applications. And you need to, because as soon as you jump to multiple application or multiple loops, you now got to talk between those loops, right? That's a huge deal. And so talking about communication, you want to ask yourself, how am I going to communicate between these loops? There are lots of ways of communicating in LabVIEW. And some of the key things you want to ask yourself is what data do I need to share? What rate does that data need to be shared between the loops? How many writers and readers do I have? What's the scope of the communication? Is it in the same sub-VI? Is it in the same application? Am I communicating between different targets? Should I use a message scheme to talk back and forth, or some sort of shared state to talk to them? So lots of questions there you want to ask yourselves how to communicate between the loops. And then once you figure out some of those answers, there's lots of different APIs in LabVIEW. You've got local variables, we're all familiar with those. You've got queues, functional globals, DVRs, which I showed a little bit there, notifiers, global variables. So different options, and an application can use any of these or all of them. And I think we use almost all of these in SquareBattle. So talking about global variables real quick, there was a session before this one that I think was titled "Global Variables Aren't Evil," something like that. I'm of the same opinion. I think global variables get a bad rap. I've seen a kind of a progression. Global variables are really easy to use, simple API, and so a lot of beginners will start using them and say, hey, these are great. I can store all my data here and then read them anywhere I want. That's great, right? The problem is they're easy to use, but they're also easy to abuse. And they can get you into race conditions and get you into a lot of problems. And so I think because of that, globals get a bad rap because they're used incorrectly a lot of times. And so I've kind of seen this progression as people move away from them, and then as people get further on in their and they mature more in their programming, in their LabVIEW use, I've seen a lot of developers kind of move back to globals. And it kind of follows this quote by Oliver Wendell Holmes Jr. about simplicity versus complexity. He said, I would not give a fig for the simplicity of this side of complexity, but I would give my life for the simplicity on the other side of complexity. I think that's very applicable to globals here. If you're using globals on this side of complexity, you're going to run into a lot of problems or potential problems. But once you understand all the complexity that's involved there and use them correctly, you move to the other side of complexity, and they can be a simple, elegant way of communicating. And one of the main ways of doing that, I believe, is to have one writer and many readers. Okay, if you're only updating your global variable in one place and then letting a whole bunch of other places read it, then you're going to avoid a lot of the race conditions and a lot of problems. Okay. I think they are more efficient than LabVIEW 2000 globals. They're very efficient in memory usage. Yeah, it's one of the most efficient ways of doing it. Some other very nice things about globals, they're very easy to search for in LabVIEW. You can see right where all of them are read and written to. It's a great way to do it. Some very simple API. You've got one node to read, one node to write. They're easily used inside sub-guides, so your scope works really well. And Darren Naviger likes them, so that's another great benefit of global variables. Okay, I was going to show that in SquareBattle, but we're running out of time, and I want to do a demo towards the end, so let's just jump ahead. The LabVIEW classes real quick. So who's used classes before in LabVIEW? Ooh, about 3/4 of you. Great. So I'll run through this real quick then. So a class in LabVIEW, for those of you who haven't used them, is basically a special cluster that has methods attached to it. Nice way to say it. One nice feature of classes is called inheritance, where you can have one class that inherits from a parent class, and you get all the benefits from that parent and the child. But you can add stuff to the child to override stuff from the parent. So if a parent has certain methods associated with it, you can override some of those methods and say instead of running the parent method, I want to use my own method and do something a little different when that method's called. That's called overriding methods. And then when you use the parent wire in LabVIEW and pass that around, and then maybe use call a child from that parent wire, that's called dynamic dispatch, which is what we use in SquareBattle to do these children classes. So it makes it really easy for people to write the competitor, the square, and plug it in, which is what I want to show. So I'm going to demo that here real quick. All right, so this is our parent class called Square. And Square is very simple. It actually has no class data. That helps reduce the time it takes to make copies of it, to keep things very efficient and quick. And we only have 6 methods in this parent. Some of them are just reference methods, like board size will tell you what size the board is. Round will tell you what round we're on. And then we've got stats that tell you the stats, kind of the similar stats I showed you earlier that are up here: generated, eliminated, kills, and collisions. That you have access to. And then we've got 3 other methods that are set to be overridden by children. We've got player info, which tells us the name of that class or the competitor. And then we have a victory speech and a defeat speech, which you can specify. So when you win, you can gloat. And then we've got eliminated, which if you want to know when each of your squares is eliminated, that's a helpful one to do, but not necessary to override. And then the main one we do is run. This is where all the action happens. This is the VI that gets called for each square every round. Okay? So if we go back to our game engine, as we iterate through this nested for loop, there's the main run method right there. So when you override this method and you write code, this is the code you write for your competitor, and it gets run right there, and that's where it all happens. And so as we talked about earlier, this run method, what you get as inputs are the row and column, so you know where you are in the arena. You also get an input, which is your team index. So for Assassin, the team index will be 0. Sir Robin, the team index will be 1. So it just has a list of the team indices. And then you've got this view here. This is your view of the world. This is an array of indices, which are the 8 squares right around you, with the first indice being the northwest direction, and then it just goes around in a clockwise circle. And what it tells you is if it's -1, that square is empty. If the team index matches what's in there, then it's a friend of yours. It's a teammate. If it's a non-empty one, that's not your team index, then it's an enemy. And so that's what your view of the world is. And based on those inputs, you have to decide what action you're going to do. Just an enum with those 4 actions we talked about: wait, move, attack, and replicate. The move, attack, and replicate actions have a corresponding direction that goes with them, and that direction mirrors what the view is. It's an enum with 0 to 7 numeric values that correspond to northwest, and then all clockwise. And then if you choose to replicate, we also have an output that is your replicated class. And this can be either the same class that you are, or you can, as someone pointed out earlier, you can have a different class be output for that. And that's it. That's the view of the world, and that's the main VI that we want to override.
Do you always start with 1 square? Because that range doesn't look like that.
Yep, every time it starts with 1 square, and you're going to replicate from there.
We just have a speed turned up on me.
Yeah, we had it go really fast. So yeah, it started out with one square and just replicated to get all the ones we saw. Alright. Okay. So we got about,
The initial position is random.
what's that?
The initial position
Semi-random initial position that spreads them out so they're not right next to each other.
And offsets.
And offsets them a little so you don't know where everyone else starts.
I mean, the very first square.
Yeah, the very first square, the starting positions for all the players. Yeah. Okay, so now that we look at the square, I'm gonna demo creating a new one, and I'm gonna create one called Galaxy that I wrote. I think I wrote it at the same time as my LabVIEW class was doing this, and it was about 20 minutes worth of work. I'll do a little faster here because I know what I'm doing, but it's very, very simple one to write, and it ended up being pretty competitive. Very happy about it. So, okay, we're going to go to our new computer, create a new class. I'm going to call it Galaxy. I'm going to save that class. And I'm going to save it in a special auto-populating folder so it'll automatically show up for us. Digits, SquareBattle, squares. Under mine, we're going to create a new folder called Galaxy. First thing I want to do to that class is inherit from the parent square class. So we right click, go to Properties, go to Inheritance, and change Inheritance. And then we want to pick our top square class and say Inherit from Selected.
And here's where, if you wanted, you can also inherit from one of yours that are descended.
And so now Galaxy has all the methods and data, although there's no data for the parent class. It gets all the methods and properties of the parent class. And so now we can right click on Galaxy and say New VI for Override. And it automatically knows that, hey, the parent class has specified these 3 functions that can be overridden. And so we're going to pick player info, save that. And here's where we specify information about it. So we're going to call it Galaxy. Victor's speech will be out of this world. Feed speech we'll set as obliterated. And that's it for that one. Then all we have to do now is override run. Save that. Get rid of the parent method. Okay. So I'm just going to pass the class wire through. And then whenever I replicate, I'm just going to make a copy of myself. So I'll just pass the wire there. I'm not going to even use row or column. Pull those out here. All right, and we also have this common library here of common things you can do in SquareBattle to make it easier for everyone to get started. I'm going to use one called Find Enemy, which takes my team index and the view. And this is pretty simple. All it does is iterate through that view and looks for an enemy there. So it looks for a non-zero one that's not equal to my team index. Okay. And if there is an enemy found, I'm going to create a case structure here. If there's an enemy found, I want to attack that enemy. So my action in that case is going to be attack. And the direction will be whatever direction I found that enemy in, which the scale will give to me. Okay? Everyone with me so far? Questions? Okay. In my false case, this is when an enemy is not there. I want to either replicate or move to find someone to attack, right? That's kind of the whole balance of this game. And so I'm gonna certain percentage of the time I want to replicate, a certain percentage of the time I want to move. So I'm going to get a random number here, which will give me a number between 0 and 1. And I'm going to say, just because I've tested this out before, I'm going to say 7% of the time I want to replicate. Okay, so if our random number is greater than 0.93, then I'm going to replicate. Otherwise, I'm going to move. But I don't want to run into myself. I want to be safe. And so we have another helper VI here that's called wait if occupied. And all that does is look at what your action is and where you're trying to go and your view around you. And if you're going to run into yourself, then don't do it. Just wait instead. Okay? So if you're going to run into one of your teammates, then just wait. So I'll keep us a little bit safe. And so all that's left is which direction do I want to move in. So to keep things simple for this guy, and so I don't run into myself or have two VIs run in the same square, I'm just going to have all my VIs move in the same direction for any given round. Sound good? And so we know from our parent class we had that round VI, so I'm going to drop that so I know what round it is. And then on the round 0, I'm just going to move northwest. Round 1, I'm going to move north, and I'm just going to go around the circle. Okay? And so I'm going to mod the round by 8 and use the remainder as my direction. Does that make sense, everyone? Okay. And that's it. I think I've made all my outputs here. Let's go ahead and run this. Let's try it. So we saw rain earlier, right? That's a fun one. Let's do rain versus this new galaxy. And you see, notice galaxy just automatically shows up here. Okay, let's slow this down a bit. All right, so rain's doing its thing. Galaxy looks like it's already started to replicate. Speed it up a little bit. So it's kind of spinning around, but it's kind of staying clustered together. So it's doing okay, but rain's still dominating here. We are almost out of time. So I can see it's kind of getting lumped up in itself and stuck, and rain took it out. So what if I, instead of just moving one direction each round, what if I moved everything, northwest for, like, say 15 rounds, and then north for 15 rounds, kind of spread out a little bit. That was my next iteration or thought on this one. So let's make that change real quick and see how that does. So we go back to our code. I'm now going to say, okay, every 120 rounds, we're going to mod it by 15. And now we take the quotient and wire that in. So what that'll do is, first 15 rounds will go northwest, next 15 rounds will go north, and so on. Okay, so let's try it again against rain, galaxy. You can see it spreads out a lot better. You kind of see the whole galaxy shape going on there. And he's spreading a lot better and doing a lot better against rain now. And so again, each iteration, each of these squares is running that little piece of code that we just wrote together. And that's all that's happening here. And you can extrapolate that out over 2,000 rounds and over up to 12,000 squares, and this is the result. And it's kind of a cool thing to watch how your code can affect that many things so quickly. Okay. And then let me try it one more
You want to say something about the tournament?
battle here? Yeah. Let me just start this run. I'm going to do Galaxy against Pinwheel and let that go while we talk. Did you want to say something? Or did you want me to say something? Yeah. Okay. So yeah, we've got the tournament going on down on the demo floor. The winner at the end of the week, I guess tomorrow, is going to win some noise cancellation headphones. So far, we only have one entry, which is Quentin. So he doesn't want any of you to enter into the competition. So he gets the headphones. You can see it can be really quick to create a square. All this code's available online. You can grab it and have one of these demo squares as a starting point.
If you have your computer with you, you can just do it down there.
There's a computer down there you can work on, or you can work on it yourself and email it to us and we'll enter it in. And we'll have our competition tomorrow at 4:30 on the demo floor at the stage. we'll take the 4 top entries and do kind of a face-off. What's that?
Red one that's more than 2 players.
Red one that's more than 2 players? Yeah, we can do that. Okay, any other questions? Yeah.
The tournament, are there any arbitrary rules we should know about besides the limitations in the framework itself?
Okay, so he's asking what rules there are.
I noticed you implemented like a penalty on one of your squares. Like, is there a reason that you did that, or is that just
A penalty? I'm not sure what the penalty is.
waited a certain amount of time? And then
Oh, it's just, that was just to keep myself from running into myself, is all that was.
All right.
Yeah. Yeah, come talk to us about rules, there's just whatever makes sense.
Okay.
Don't do anything stupid, crafted or anything like that.
Don't use eggs on LabVIEW.
Yeah, don't no pop-ups or, yeah. Yeah. Let me start this real quick here. So you can do more than 2 people. Lots of different squares compete as well, which is kind of fun. So come down to the floor. We've got this continually running. We've got a leaderboard set up down there to show who's currently winning, and you can see all these duke it out there. Any other questions? All right, guys. Thanks for your time. Appreciate it.